Hello, welcome back to the session. Today we're going to discuss about troubleshooting and the future of internet session 2. In the previous session we have discussed about the various troubleshooting methods that we use to resolve the issues in the network. Whether a user is not able to access internet, whether the user is not able to connect to the local server, or not able to access the application which is either within the office or maybe in another office of the same organization. So troubleshooting involves identifying the problem and resolving the problem. So we have discussed in the previous session very detailedly about the various issues that can arise in the network. They could be physical problems like the connections, the cables, the disconnection of the cables, etc. Or it could be because of the encapsulation, speed or duplex mismatches. Or it could also be because of the IP address properties like IP address, subnet mask, default gateway, the DNS server. This could be the various issues. So that's part of the troubleshooting. So today we will spend more time on understanding the future of internet. So what do we mean by future of internet? So if we look back where it started and how it has progressed to what it is today and what's going to be in the future. So it started way back in the 70s and 80s, where the term internet referred to a global connection of networks. Today if we have to define internet, it is providing providing connectivity to the ISPs across the globe. All the ISPs across the globe are interconnected, and that provides a backbone of internet. And if a user connects to the internet service provider, he has access to the whole of internet. And in a similar way, we have the service providers, the content service providers. For example, Google. Google provides a lot of services like news, email and various other applications that they offer, search engine, so many other features they offer. So this is what they offer for the end users or even organizations, corporations, education institutions. So likewise we have Yahoo and Rediff and so many other providers, content providers, information providers. Even the college universities have their own websites, and some of them even run distance education programs which are online programs. So for that there is content available on the servers. So these servers also are connected to the internet. Those who are providing the content are connecting to the internet. Those who want to access internet are also connected to the internet. So when the user who wants to access the server connects to the internet, with the help of this internet service providers, he is able to access the resource. So in the previous session when we did a trace route to google.com, we were the end user. And google.com was somewhere on internet. So with the help of the ISPs, we were able to reach that particular web server or email server. So we have an end user, we have the internet and the content or the destination or the resources. So the content provider should be connected to internet, the end user also should be connected to internet, and then we have access to the internet. So globally all the ISPs are interconnected. If we look at in India, we have providers, ISP providers like BSNL, Airtel, Vodafone, Tata, Reliance, so many different ISPs we have, Act Fiber and so many other smaller ISPs as well. So all these are interconnected at some point, and hence a user who is using, let us say, BSNL internet will be able to access the server which is hosted in maybe in Airtel network or Tata network or Reliance network. So these are all interconnected. So similarly, these ISPs in turn are connected to the global ISPs. Let's say for example, AT&T in America, or Singtel in Singapore, or Telstra in Australia, or Vodafone in UK. So they are all interconnected. Globally, the ISPs are all interconnected, and they are taken care by these registries. We have discussed the IPs are allocated by the INA, Internet Assigned Numbers Authority, and under that we have regional internet registries, and under that we have ISPs. So, internet has grown from a basic simple file transfer mode in the 70s and 80s. Today we have real time video, high definition video, audio and text, animation, everything. We have almost everything that is available today. But what's going to be in the future? So let's look at some technologies that will help us to know the future of internet. It's already in progress, but it's going to have a bigger impact later on. So let's look at what we have today in the discussion. We have the cloud technology, the Internet of Things, and IPv6. So these are going to be the future of internet, or these technologies are going to innovate, or these technologies are going to provide the scope for the internet of the future. And these technologies are already started, they are already being in use, but they will become a bigger scale, larger scale deployment will happen. The cloud technology. So what is available in the technology? What are the different models available in cloud technology? And it is evolving in a very big way. Every organization has in some way or the other, whether knowingly or unknowingly, is using the cloud technology. All of us, you and me, are also being part of this cloud technology. I hope everybody of you have an email account, either from Gmail or from Yahoo or from some other provider. So where are our emails stored? They are stored in some space on internet, and all these providers, Google, etc., they're all storing this in the cloud. The emails that we send or receive are stored in the cloud. So when you connect to your email provider by logging into your email by using the username and password, we are getting access to that information, and they are stored in the cloud. So we are benefiting from the cloud technology. And most of us who have the Gmail account, they also give space. They give 15 GB of space to store your personal information, maybe music files or maybe pictures or some videos. So the Google Drive is also an example of cloud technology. Similarly, there are other vendors providing different amounts of space, and they are also stored in the cloud. So let's look at what is this cloud technology and what are different models used and for what purposes they are used. The cloud technology offers a shared pools of configurable computer system resources and higher level of services that can be rapidly provisioned with minimal management effort, often over the internet. Cloud computing relies on sharing of resources to achieve coherence and economies of scale, similar to public utilities. So this is just a definition which is picked from the Wikipedia. That's what it means. So cloud computing is shared pool of configurable computer system resources. Prior to cloud technology, if I have to have one web server, then I have to buy a physical server, I have to buy the network operating system, and on top of that I have to buy this web server application software. And by installing these applications on this physical server, I need to ensure the web pages are also deployed on that server, and then an internet connection is provided to the server. To ensure this internet connection, we have to look at backup, and then we have to ensure that this server is running 24/7, so there should be power backup, and there should be a technical person to manage this server physically in our office or in our college. This server should be running 24/7 because we are connecting this server to the internet, and people from internet, they can access this server anytime they wish to. So in this case, we have the server physically in our premises, making sure that it is running all the time, and internet is also available all the time. So this kind of service is required before the cloud technology. Suppose I want to have another few servers, so then I have to buy physical servers, install them, and then provide the access. So it's a time taking process. But in the cloud, with just a click of a button, the server is created, and you can just copy the web pages into the particular server in the cloud, and you can start running the services. It is the cloud service provider's responsibility to ensure that these servers are running 24/7. They have the power backup, they have internet backup as well as security. So, all this is taken care by the cloud service provider. So, we are just using the facility. So, if we have to do it in a traditional form, so you see the process, buying the physical server, they are not easily available. If you want a high-end server, if you order, they will take few weeks to deliver the server. And then we have to install the operating system and then install the applications, and all this is a big process, time consuming process. But with the cloud technology, it's just there as and when you require. On demand, you have an on demand server and you can bring up the server in very quick time. These are the benefits of the cloud technology. So, let us see the different cloud models. These are the various cloud models available in use. So, we have the cloud technology number 1, which is software as service. Software as service is one of the cloud computing models, and you can see in this the examples that are using this SaaS model. Google Docs or Google Drive, which we are familiar with, Gmail. These are the two popular ones. So, if you are familiar with applications like Salesforce, which is a CRM application, okay. So, these are the various examples of SaaS models, software as service. We will be looking at what this means. We will be looking at how this works briefly. The second model of the cloud computing is the PaaS model, also called platform as service. Platform as a service. This is called as PaaS. Software as a service is SaaS and PaaS. So, we have Microsoft Azure and Google's App Engine and Force.com. These are the examples of the vendors who are using this platform as a service model. And then the third one is infrastructure as a service, IaaS. Infrastructure as a service is the third model, where they provide infrastructure like Rackspace is one of the organization, GoGrade and AWS. GoGrade belongs to Google and AWS belongs to Amazon Web Services. So, these are the various examples of the infrastructure as a service. So, this is just to give you an idea of the various cloud computing models available. We will be discussing a little more in detail about each of this model, and then get to the next, that is Internet of Things. So, the first one, software as a service. It is basically a cloud computing model which is the most popular among all of the models that we have seen. The three models that we have, SaaS, PaaS and IaaS, among these three, the software as a service is the most widely used model. It provides fully functional web applications on demand as and when required. So, some of the organizations that are providing this service is WebEx, Cisco WebEx, which is providing the web conferencing solution. Then there are companies which are offering ERP, something like SAP, and then CRM applications, that is Salesforce, customer relationship management, and email providers like Gmail and project management. So, these are some of the examples that are implemented using the SaaS model, software as service. And what are the benefits, other benefits that we have from this model? You can access SaaS application from any location with just having an internet connection. It may be from your mobile phone, it can be from your tablet, it can be from your PC, it can be from your laptop. You can use the SaaS model with just an internet connection from any of the devices that you have. So, it is very flexible, very easy, and on demand you can access. This is the advantage of this SaaS model, the benefit of the SaaS model. Then it eliminates the infrastructure cost for the end user. Suppose I want to have a server, physical server, it costs me a lot to maintain one single server. So if you go to the SaaS service provider and you can host your application, you don't have to buy anything physically. Suppose you have a project for 6 months and you want this website to be available only for 6 months, then it's not conducive to have a physical server and you buy this infrastructure, very expensive things. But instead, you can just host this server services on a web platform or SaaS platform. So after 6 months, you can just close your application. So it eliminates the costs. And then the service providers, SaaS service providers, provide maintenance and support. When you hire the services, they will provide maintenance and support. Rapid scalability. You can have your servers up and running in very less time. And they also offer custom levels of service, like you can customize. I want this service, I want that service, I want this service for this much amount of time, I want this much bandwidth to be available for this particular application. Suppose, just an example, if today there is an announcement that Apple 10 phone is available, let us say for 100 rupees on, let us say, some website. So everybody will start hitting that website. Millions of users will be starting to hit that website. So that much amount of bandwidth should be available on demand. So that can be provided with this SaaS model. So SaaS provides end users a very good flexibility, and also for the service providers to ensure that their applications are running at a peak time, at a peak levels without any issues. So this is the benefits of the SaaS model, normally used for the end users. Then we have the second model, that is platform as a service. So as the name, platform as a service, this is normally used for developers. Suppose you want to develop a software application. To develop an application, you need a platform, you need operating system, you need some environment, whether it is Java or .NET or any other application that you want to develop, database application, you need a platform. And this will be only for that duration of time. You don't want it to be available for long hours or long weeks or long months. It's just for few weeks or months for that particular application development. Once that application is developed, you don't want the infrastructure. So rather than buying that infrastructure, we can take this PaaS model, platform as a service model, can be used for developers. So let's see what we have here in the PaaS model. In the PaaS model, apart from providing the infrastructure, the provider also offers computing platform and solution stack as a service. And this is the most widely used for organizations that need to develop software applications, test them whether they are working properly or not, and then collaborate and deploy on the cloud. So some of the examples that use the platform as service are the providers, the PaaS providers are Microsoft Azure, Google Apps Engine, and Rackspace cloud sites. These are the vendors who are offering platform as a service for the end users or maybe organizations. The benefits that we derive from the PaaS model are, many people are involved in building the cloud application. So there is a community. So we have a community of developers and they put together, develop this application on this PaaS model. And we don't have to worry about the upgrades, because the service provider will provide the upgrades automatically, whether it is operating system updates or the application updates. Everything is provided by the service provider. He takes care of all the updates, upgrades, patches, and software maintenance as well. If something is not working, you just have to log in a request to this provider and he will take care of this software maintenance or patches or updates or upgrades. And it works out to be a very low cost model for companies. With less investment, they can develop an application because of the PaaS model. Companies need not make any upfront investment on hardware or software. You don't have to buy any software or hardware because the PaaS service provider is offering all of them at a very less cost. Simplified deployment. The development team can concentrate on developing the cloud application without worrying about the testing and deployment infrastructure, because these are provided by the PaaS service provider. So, the PaaS model is a boon for those organizations who require an infrastructure to develop these applications. They just take the space and then they can start working on the project, and once the application is complete, and they can close a contract. So, they no longer waste a lot of resources, money, especially the money, and time as well. If you have to set up an organization just to create an application, you need space, you need hardware, you need software, you need to buy them, all of them. So, there is a lot of infrastructure costs, and that can be reduced by using this PaaS model. And the third one we have is the infrastructure as service. In this infrastructure as service, you can see this model provides delivery of pre-installed hardware and software through a concept called virtualization. Virtualization is the part of the cloud. In all the things that we have discussed, there is virtualization, but infrastructure as a service is purely based on this virtualization. Customers are free to use the services according to the business requirements. According to the business requirements, customers can use these services. For example, web hosting. You have a company's website, and this website has to be available for internet. There are a lot of companies who have a small website, and they don't want to spend more money on implementing this website. They just have their application and it should run all the time. So, these infrastructure as service providers have the provision, and they will offer these services. And there are many IaaS providers like Google, IBM. There are so many vendors who are offering this platform in infrastructure as service platform, and it is the easiest one to provide also. For the service providers, it is the easiest method when compared to PaaS or SaaS model. They have less cost on this infrastructure as service. Okay, so we have the benefits coming up as reduced total cost of ownership for the end users and less capital expenditure. Users pay for the service they want on the go. Simplified deployment. The team can concentrate on developing the cloud application without worrying about the testing and deployment infrastructure. And access to enterprise grade IT resources and infrastructure. So, these are the benefits of the infrastructure as a service model. So, with this we have discussed about the cloud and the methods or models of the cloud and who uses them a lot. So, software as a service for the end users, because they get applications like email or video conferencing or ERP application or CRM applications. This is about the software as service. Then platform as service is mostly for developers who want to develop an application or a software application. It's for them. And then infrastructure as service is for also organizations where they want to host services, web pages, etc., etc. Okay. So, we go to the next type of the future of internet, that is Internet of Things. It is the buzzword which everybody hears today. Either you hear about the cloud or you hear about the Internet of Things. So, Internet of Things is just a name, but you have a lot of things under this Internet of Everything. Now they call it Internet of Everything. Everything and anything can be connected to internet. Previously, if you want to access internet, you have to have a computer, and then through the computer you have a dial-up modem, and through the dial-up modem and the telephone connection you used to connect to the ISP. This was the model in the 80s and 90s. And by 2000 you have the broadband technology. So, there is no longer need for the modem. You only need the cable coming from the ISP and connect it to this small device, Wi-Fi router, and then you have Wi-Fi access to the internet. And then by late 2000 and then 2010 onwards, we have internet on our phone, mobile phone. We have internet on the mobile phone. So, you no longer need a PC or a laptop. Your phone is a device which you can use. So, the similar technology evolution is also happening in other space like home automation, smart homes. You must have heard these terms a lot of times. So, what do they mean? They are connecting all these devices which are used in the home home appliances, maybe refrigerator, maybe the air conditioner or the room heater or the water heater, the fans, the lights, they're all getting smart. They're getting connected to the internet. So you can operate all these equipment, even the gate, the main gate of your home, it should be smart enough that when your car arrives, the door opens automatically. Or it's a very hot day and the moment you reach home, you want the home air conditioner to be on before you arrive and the room should be pleasant. So you can operate from your mobile phone to the smart home application and turn on the AC even before you reach the home. So that's how it's going to happen in the future, and internet is going to play a big role in this and through Internet of Things. So let's look at what we have in the Internet of Things. According to Wikipedia, Internet of Things is a network of physical devices, vehicles, home appliances and other items embedded with electronics, software, sensors, actuators and connectivity, which enables all these gadgets and things to connect and exchange data, creating opportunities for a more direct integration of the physical world into a computer-based systems, resulting in efficiency, improvements, economic benefits and reduced human exertions. This is the definition, technical definition of Internet of Things. In short, it represents the same discussion we had just now. We are able to interact with all our home appliances, which is also used for industrial use, not just for home. It's used for industrial use, and many industries are getting benefited from this kind of model. So what we can do with Internet of Things, what we can foresee in the future of internet with Internet of Things. So if you look at this picture, in this picture we have various devices. You can see here devices we are already using. You can see here devices we are already using. This is the devices we are already using. Laptops, smartphones, tabs, PCs, we are already using. And devices previously inactive for the data world, but now intelligent. The lights, the smartwatch, the tracking devices that are available, smart cars, and completely new devices, virtual reality. We discussed about virtual reality, and then devices using connectivity in new ways, smart TV, smart home. Even industries are using this for their benefit and advantage. So all are going to get integrated. All these are going to get integrated into one system. Traffic monitoring, Internet of Things, the web cameras that are placed on the road, streets, is looking at the traffic and intelligently providing the signaling system. Temperature controls. In industries, there are a lot of things that have to happen in very quick time. So there are sensors which is sensing the required parameters and then accordingly taking action. So Internet of Things is going to be the future, and there's going to be lot of opportunities. Internet of Things, the cloud technologies, they're going to provide a vast majority of opportunities. But for all this, understanding the networking is very important. All those sessions we have discussed is going to provide as a base for providing knowledge to understand these concepts of Internet of Things and cloud. So we have the Internet of Things, and we will also look at the other functions of this Internet of Things, which according to Wikipedia. So Internet of Things involves extending internet connectivity beyond standard devices like smartphones, tablets, computers, laptops. Beyond that, we want to take it into non-internet enabled physical devices and everyday objects, what we use every day. So already we have smart TVs. Even though you don't have a smart TV, you can just on your available TV, if you have a HDMI port, you can just buy a dongle from the various vendors and then you can connect, it becomes a smart TV. So you don't have to invest on a new smart TV, but your existing TVs itself, you can make them smart by just adding small components. Okay. And then we have embedded with technology, these devices can communicate and interact over the internet, and they can be remotely monitored and controlled. With the arrival of driverless vehicles, the branch of IoT, that is Internet of Vehicles, starts to gain more attention. So as I mentioned, that Internet of everything, we started with Internet of Things, but we are going in different ways. Internet of Vehicles. So there are already some tests going on where the driverless cars have a mechanism that they are called autonomous cars. You just tell them the destination, they will navigate using the Google Maps and take you to the destination. By avoiding all kinds of obstacles that can arise, traffic, they monitor the traffic signal, and collision avoidance. If there is some other object coming in opposite direction, they have the mechanism, they have the protocols where they can interact with the cars. The cars can talk to each other using the protocols and then ensure that there are no accidents. Globally, there was a survey which said there are millions of accidents happen all over the world and a lot of people die. But with this concept of Internet of Things and Internet of Vehicles, autonomous cars, then we can reduce this rate of accidents and have a peaceful life. You can have a happy driving instead. But for this cloud and Internet of Things to work effectively, there is another important thing that we discussed in the earlier part of the course, that is IP address. Every device that sends data or receives data must have an IP address, but the existing IPv4 addresses is no longer available for new devices. Means the IPv4 addresses are completed, they are finished. We don't have any IPv4 addresses available. But for a device to be part of a network, it requires an IP address. So we are going to look at next about IPv6. So IPv6 is an important feature because it has billions of IP addresses. IPv6 is going to be the future of addressing to ensure that the cloud technology grows to an unlimited space. The Internet of Things, you can add many more devices into your current network, monitor them, control them remotely. So every device requires an IP address. Today your phone, your smart TV, and these are only the ones which are having the IP address. But once Internet of Things comes up, your gate will have an IP address, your refrigerator will have an IP address, your fan will have an IP address, your light will have an IP address. So all these are going to require millions or billions of IP addresses, and these are provided by this IPv6. We had in the previous sessions learnt a little bit about IPv6. So you can see the current IP version 4 has only 32 bits, and you have IPv6 as 128 bits. So this is four times bigger than the actual IPv4 address. Okay, and then it is represented in a quadret notation, and it is in the hexadecimal format. So we can have a look at the address on our computer. When you give the command ipconfig, and then you can verify whether there is an IPv6 address or not. So you can see here there is an IPv6 address 2001:0:0:1234:1234. This is a representation of an IPv6 address assigned to this computer. So we can assign IPv6 address to the devices. Majority of the devices support IPv6, and it's not a new protocol, by the way. IPv6 was launched in the year 2000, and we are in 2018. So 18 years passed and it's still in the nascent stages. There was global statistics about the usage of IPv6. The whole of the internet traffic, when you look at the protocols, IPv4 traffic and IPv6 traffic, approximately 20 to 25% of the traffic only is from IPv6, and it's supposed to grow. As more and more devices come onto the internet, we have to use IPv6 as a communication protocol. So IPv6 has a lot of scope because of its addressing scope. because IPv4 was only 32 bits and it could provide maximum of 4 billion addresses, and many of them are reserved and they are already exhausted. There are no longer IP addresses available in IPv version 4. So, we only have in IPv6 billions of IP addresses. So, you can also visit this website aina.org. So, we can just go to aina.org. Just to give you a quick output, www.iana.org. So, this will take us to the web page and provides us the information about both IP version 4 and IP version 6. It's taking longer than usual. Okay, so it's coming up. So, Internet Assigned Numbers Authority. This is a global body which provides information about the registries and the addresses that are allocated. Okay, so you can see here in the web page, there's a lot of information, and what we are interested is the number resources, and you can see here IP address and AS numbers. So, just click on this IP address and AS numbers. It will take us to the page which has IPv4 and IPv6 addresses. Numbers represents IPv4 and IPv6. So, you can see here these are the various registries we have globally. Afrinic is for the Africa region, APNIC for Asia Pacific. India is part of this APNIC region. India and most of the Asian countries including Australia and New Zealand comes under this region called APNIC. Then we have ARIN for North America, Canada, USA and some Caribbean islands. LACNIC for Latin America, that is South America and some Caribbean islands, and RIPE is for Europe, Middle East and Central Asia. So, the world is divided into 5 regions called Regional Internet Registry, and you can see here the IP address allocations. Because this is a global body which allocates both IPv4 addresses as well as IPv6 addresses. When we go to this IPv4 address space, when you click here, and you can see that the allocated IP addresses right from class A, class B, class C, class D and class E, all the 5 classes we can verify here. This will provide us information relating to IPv4. So, you can see here the first address 0/8, this is a class A address starting. You can see it is reserved, it is not allocated to anybody. So, the allocated IP addresses start from 1.0.0.0. So, it is allocated to a registry called APNIC, Asia Pacific Network Information Center. So, similarly you can see the various IP addresses allocated to different registries, and some of them, you can see this 4. IP address 4 was allocated to an organization called Level 3. This is an ISP in the US, and when was this organization allocated this IP address? 1992. In the year 1992, this IP version 4 was allocated to this organization called Level 3. And then later on you can see that some of them are private IP addresses which are free for every organization to use. The private IP addresses are free for everybody to use, and they were allocated in the year 1995. And then there are some specific IPs like 12 reserved for AT&T. It's an ISP in the US, allocated in 1995. Apple organization, allocated in the year 1992. The IP address starting from 17 is allocated to that organization. And you can see 19 allocated to organization Ford Motors in the year 1995. So, after a while, when the IP addresses were getting finished, they stopped offering these IP addresses to the end customers, and they are routing all the IP addresses via the regional internet registries and ISPs. So, this is about the IP version 4, and we have seen the usable addresses are only up to 223, and there is a reserved addresses, that is 127, which is reserved for loopback. 127 is reserved for loopback. You can see here 127 is a reserved address, 0 is reserved and 127 is also reserved. And then class B is from 128 up to 191, class B range of IP addresses. And then from 192 onwards is class C. So, class C starts from 192 and goes on up to 223. So, goes up to 223. So, that is the last IPv6 address, which IPv4 address which we can use in our networks. From 224 it is multicast addresses up to 239. Up to 239 is the multicast IP addresses. From 240 up to 255, which is the last IPv4 address, they are reserved for future use. Also, we say it is reserved for research and development. So, this is a small overview about IPv4. Let us go with IPv6. This is IPv6 address space. In this IPv6 address space, we have the various pools of IPv6. You can see 0 is reserved, 0100 is reserved, we can say it is 100 is reserved, 200 is reserved, 400 is reserved, 800 is reserved, 1000 is reserved. From 2000 onwards it is available for use. I repeat, the IPv6 address starting from 2000 onwards it is available. The reason why they have kept this aside was just to coincide with the year that IPv6 was launched. The IPv6 addresses were launched in the year 2000, and hence the public IPv6 addresses starts with 2000. But that is not the only thing that is important, but there are so many other addresses that are reserved for various purposes, like for private IPv6 address. Public addresses start from 2000, then private addresses are reserved, then multicast IP addresses are reserved, link local addresses are reserved, loopback address is reserved, and default addresses are also reserved. Similar to IPv4, but there is a difference. In IPv6 we do not have classes. In IPv4 we have class A IP address range, class B IP address range, class C which we can use, and class D is reserved for multicast and class E for future use or research and development. Whereas in IPv6 there are no classes and there is no broadcast. So, with this we have learnt a lot of things about the future of internet, that is cloud technology, the Internet of Things and IPv6. Thanks for watching this video.